Welcome back to my course Aspects of Biochemical Engineering. I was discussing last couple of lectures on the different biochemical processes, and we try to understand that how the chemical reaction kinetics can be applied in the biological system for better understanding on the process like enzymatic reaction kinetics and the microbial growth kinetics. And after that I try to discuss the transport phenomena, how different transport mechanism that involved in the bioprocess. Then finally I also discuss some kind of upstream processing like like we have air sterilization and medium sterilization, which appears to be the very important as the biochemical industry is concerned. Now, downstream processing in other way plays very important role in the biochemical industry because the purification of the product is essential for increases market value. And if we look at the type of chemicals that is available in the market, that is of two type. One is of analytical grade, another is commercial grade. Analytical grade, the purity of the chemicals is more than 99.9%, and commercial grade about 90-95%. So the cost difference is huge because the analytical grade may be as high as 4 times as compared to commercial grade. So purification process, we require lot of steps involvement that I want to give a typical example of the citric acid industry, where we find that citric acid is produced by aerobic fermentation process using Aspergillus niger from cane molasses. And after citric acid formation, what you do, first we separate out the cells, then the filtrate we pass through the treat with lime for the separation of in the form of calcium citrate. This calcium citrate I separated with the help of some kind of filtration, and then calcium citrate hydrolyzed with sulfuric acid from gypsum, and citric acid gypsum again separated out with the help of gypsum filter. Then again this citric acid is concentrated in the evaporator to concentrate 22% to 60%. Then we pull it down and to crystallize this citric acid, and crystals of citric acid separated in the centrifugation machine. Then these crystals further we dried in the dryer, drum dryer, and finally we pass it through the sieving machine to get the different size of crystals, and finally we packed in the polythene pouch and sell in the market. So what I wanted to point out, the different steps are involved in the downstream processing. Now let us this particular presentation I try to discuss what are the different steps involved in the downstream processing. And if you look at in the biological system, we have two type of product. One is extracellular product, another is intercellular product. Extracellular product means, suppose this is the cell, and if the product comes out of the cell, and then it will be easy for separation, because we separate out the cells, then filtrate, we purify to get the product. But intercellular cells is something different, the product present inside the cell. So we shall have to break the cell wall so that the product should comes out from the cell, and then we can purify the product. This is exactly that has been shown here, that filtrate come this way, and this way then we have solid liquid separation, we do the concentration, purification, and we do the formulation, and then we have the final products. Now in the different steps we have different type of downstream processing involved, that in case of cell disruption we have chemical, enzymatic, mechanical and physical processes. Solid liquid separation, we have centrifugation, sedimentation, extraction and filtration. In case of concentration, we have evaporation, ultrafiltration, adsorption and precipitation. Purification, we have chromatography, and formulation, we have crystallization, freeze drying, spray drying, and the sterile filtration. Now this downstream processing again varies on the different parameters. As for example, if we with respect to size, we have filtration, that membrane the separation and centrifugation. If we wanted to separate with respect to density, then we have centrifugation, sedimentation and flotation. Now with respect to diffusivity, we have membrane separation. With respect to shape, we have centrifugation, filtration and sedimentation. Polarity, we have extraction, chromatographic and the adsorption. Solubility, we have extraction, precipitation, crystallization. Electrostatic charge, we have adsorption, membrane separation and electrophoresis. And volatility, we have distillation, membrane distillation and vaporization. So these are the different processes that we have involved. And the cell disruption, if you consider, this is, I told you that the main goal is to intracellular fluid without disrupting any component present inside the cell. That is the main purpose of disruption process. Now cell disruption process may be divided into two types. We can see that one is non-mechanical method, another is mechanical method. Non-mechanical method, we have physical method, chemical method and enzymatic method. Now physical method, we have freeze and thaw, and then we have freeze and thaw. We understand that we frozen the cells, then we thaw it. That means we liquefy it. So cells are they burst in between that. Then microwave and thermolysis. Then that osmotic shocks, due to osmotic shocks, cell breakage take place. Electric discharge, that also causes the breaking of the cells. And then enzymatic, we have lysozyme we use for breaking the cells. Chemicals, we have some kind of buffer we use for breaking the cell wall. Mechanical, we do it physically, that is motor and pestle or grinding, blender, beating, ultrasonication and the homogenization. So these are the different techniques through which we can do this cell disruption. Now some pre-treatment is required, is used primarily difficult to filter the slurry, enabling them to be filtered more easily. So we first we separate out the bigger cells, so the small cell will not pose much a problem to the separation processes. It is usually involved changing the nature of suspended solid by either chemical or physical means, or by adding the solid filtered to the suspension. Now pre-treatment, we have two types, one is chemical and another is physical. Chemical, I want to tell you, suppose the bacterial cells, they are very small in size, 0.5 to 2 microns. Now this, due to the small size, it is very difficult to separate them. So what we sometimes require some kind of filter aid, so that the accumulation of the cells take place and particle size increase, then it can easily settle down. So this is a kind of what we call flocculation. Then coagulation, we know we use the alum in the water treatment process to separate the colloidal matter present in the water. pH adjustment, there is another technique that we have. A physical method, we have filter aid addition. I can give the example of Solka flock. Solka flock basically is cellulosic material that is used in the chemical and biochemical industry for the separation of activated charcoal. Activated charcoal is a fine particles, and if it present in the product, it will look like black, and that is not permissible. So Solka flock is used. Freezing and aging, that is another process that we use. Now solid concentration can be done in two ways. One is sedimentation, another is centrifugation. Now in case of sedimentation, I told you that suppose this is a vessel, and you keep the suspended particle like this. So what will happen with respect to time? You will find this particle will settle down like this. Am I right? Now this settle down of the particle is due to the gravitational force. So sedimentation is the process letting the suspended particles settle by the gravity, which is a natural force. In sedimentation, the particles which are denser than the liquid media would settle and form a zone heavier, very high percolated concentration. So here we will be concentrating of the particle will be very high as compared to this. And we use the Stokes law for explaining the settling velocity of the particle. G is the gravitational force and this is actually acceleration due to gravity. This is rho s, this is the density of the solid, rho l is the density of the liquid, d is the diameter of the particle, and rho is the viscosity. Now, in case of centrifugal force, it is, we know in the centrifugal force settling, we have two type of forces act on it. One is centrifugal and then centripetal. Centripetal acts that towards the center, and centrifugal is towards the periphery. So your solid particle is separated with the help of centrifugal force. Now the process with the separation of the particle solution according to the density and viscosity of the media and rotor speed, and when the force is greater than the gravity is desired. Now here we can tell you that settling velocity is defined as the dc equal to omega square r rho s. If you find this portion is the same as our settling velocity, only the gravitational force is replaced, g is replaced by omega square by r. Am I right? The omega, what is omega, is the angular velocity, this is radian per second, and r is the radial direction. Now in the we have a sigma factor that we calculate on the basis of q is the volumetric fluid rate, and vg that the separation velocity that we have, settling velocity that can be that is expressed by the sigma factors. Now disc stack bowl centrifuge, we have this kind of equation that the sigma equal to twice pi omega square n minus 1 3g theta. Now omega is the angular velocity, n is the that number of disc of the stack, and g is the gravitational force of attraction, then acceleration due to gravity, and theta is the half cone angle of the disc. R2 square is the outer radius of the disc, and R1 is the inner radius of the disc. Now this is how the centrifugal things that works. When you centrifuge, the liquid will be close to the center, and your solid material will be at the periphery. The result comes out like this. This is how the solid separation takes place in the centrifuge, and this is the kind of lab centrifuge we use in our lab. This is the disc stack that centrifuge machine. We have different discs that we have. How this here, how the solid material accumulation take place. You can see it here, that how solid that take place here. Now we have a simple problem here. A continuous disc stack centrifuge is operated 5000 rpm for separation of Baker's is at a feed rate 60 liter per minute. 50% of the cells was recovered at constant centrifuge speed. If the centrifuge speed is constant, that means 5000 rpm, the solid recovery is inversely proportional to the. So what is this? What flow rate is required to achieve the 90% cell recovery if the centrifuge speed is maintained 5000 rpm. So since it is inversely proportional, I can always write 50% by 90%, that it is inversely proportional to that. That means this is to be multiplied by your flow rate, that is 60 liter per minute. Then you can find out the what flow rate is required to get this 90% separation of the cells. Now next problem is that what operational speed is required to achieve 90% recovery at a feed rate of 60%. So here we have says the sigma that is proportional to omega square, and this is again it is proportional to q. So we can write q1 by q2 equal to omega square to omega 1 square by omega 2 square. Am I right? So here what operating speed is required, speed with that means omega 2 you have to find out, and omega 1, and then 90% recovered omega 1, we know that 90% separation, we just calculate how much omega 1 is required. Q1 and Q2 we know, we can easily find out the omega 2. Now let us see how we have done here. That here exactly what I am saying, that 50% to 90% is liter per minute, we can get this is 33.31 liter per minute, and Q1. So Q1 is coming like this. Omega 1 is 5000 rpm. The Q2 is 60 liter, because we want to maintain the original flow rate. What should be the omega 2 value? So this relation, so we have, then we can find out this omega 2 value. Am I right? This omega 2 value we can calculate is coming about 6710 rpm. So this is summarized in the table, that at 50% recovery of solid at a flow rate 60 milliliter per minute, operating speed is 5000 rpm, but 90% solid separation, flow rate should be reduced to 33.31 if you want to maintain the same operational speed. But 90% recovery, if you want to maintain the same previous flow rate, then the rotational speed of the starter, that is the centrifuge machine, that will be increased to 6710. Now ultra centrifugation machine is another device where we can use for the separation of the fine particles, small particle matter. We can use, as for example, protein, RNA, DNA, those can be separated with the help of this ultra centrifugation machine, and that is usually operated at the very high angular velocity, the 30,000 to 50,000 rpm. Now you see that due to this we required lot of heat generation. For that, cooling device is required. So this is the main principles behind that is use the size, molecular weight, density, and the mobility of the particles that involve for the separation of the macromolecules present in the liquid. Now solid separation is involve the filter, in which the solid and liquid is classified by different ways. One is filtration, another is cake filter, that the cake filter divided into pressure, volume, centrifugal, and gravitational operation. Now the filtration technique is very simple. This is the filter media that we have filtered we have, and we put the suspended, this is the filter media, this is the suspension. So here the suspended material, here the suspended material that they accumulated here and filtered with percolate through this, and here we use sometime pressure, so that rate of flux of the liquid increases, and we will get more filtered flow. That when the solid is present is very low concentration, not exceeding 1% weight by volume, the process is separation of the liquid is called clarification. So this clarification basically deals with that separation of the solid from the liquid. Now we have this filtration, we have different things involved. One is slurry, then we have filter media, we have filter cake and filtrate. Now slurry, the suspended to be filtered. So this is the feed where slurry is there, that comes in the form of slurry, and that is to be filtered. So we put some kind of filtration media. When the porous media is used to retain the solid, then we have filter cake. This we accumulate of the solid on the filter, that that the cake formation is there, and that whatever clear liquid comes out, we call it filtrate. Now filter media, that function of filter media is primarily acts on impermeable barrier to the particulate matter. I can give the example here, that if you look at this is the filtration media, and this is how this particulate this accumulated on the surface, and in case of surface filtration, and in case of depth filtration, the particulate not only accumulated at the surface but accumulated inside the pore also. So we have, this is some resemblance with your filter, that fiber filtration. Also we have shown you that particles how they are entrap within the fibers. So this is the solid liquid separation, filtration offered the cake filter because of continuous deposition of the cake on the suppose we have filtered and solid particles that accumulated on the this is how the cake development, cake filtration take place. So filtered media will be, we have filtered paper, oven filtered like cheese cloth, oven polymeric fiber, oven glass fiber, non-oven fiber plate, sintered and perforated glass, sintered and perforated metal, ceramics and synthetic fibers. So different type of filtered media we can use. And here type of filtration we can see, this is the suspended particle, when it is settled down, this is the filter media, and this is the how the solid particles that deposited on the surface of the filter media, and this is called cake filtration. And then it is the kind of filter that where this feed is going and you will get the filtered, here also you get the filtered, and here suppose you have a fixed filter media and your flow is like this, and then filtration take place in this direction, we call it cross flow filtration. Now mechanism of filtration we have different, we have surface filtration, we have depth filtration. In case of surface filtration, particles are not allowed to enter into the filter media, that I have shown you, I have already shown you, and cake filtration or cross filtration are based on surface filtration. But in case of depth filtration, particles are allowed to penetrate in the pore and pore network present in the filtration media. They are retained within the filter by three mechanisms: direct interception, inertial impaction and diffusional interception. Because these all principles I explained during the air filtration process. Now this I have already explained. There is some material entrap inside that, like your that air sterilization process, this occurred. In case of surface filtration, the particle remain on the surface of the filtration media. Now the constant pressure filter cake, that filtration process, that where the filtration, where the driving force is kept constant, the flow of liquid through the filter is depends on K into A into del P rho by L, where K is the Darcy law of permeability, A is the area and of the filter, del P is the pressure difference across the filter media, rho is the viscosity, L is the thickness of the filter media. Now Q is the kind of flow rate the passing through the filter media is again Q equal to A into del P mu into Rm. Rm is considered as the media resistance, and so Q is the flow rate. This can be expressed as dP by dt, and this is again will be equal to this same formula that we can put it here. Now finally, there is constant pressure cake. We have this equation dP by dt del by dm Rm by Rc, while the Rc is the cake resistance. So the thickness of the cake deposited is proportional to the cumulative amount of heat filtered, and hence the cumulative volume of filtrate, and the cake thickness is inversely proportional to the filtered area, and it can be written in this form, whereas alpha is the specific cake resistance meter per kg, and Cs is the mass of cake solid per unit volume of the filtered, expressed as kg per cubic meter. Now this equation we can write in the form of T, that if you solve in the form of T, then we can write T equal to this equation, and this we can simplify in the form this K equal to Kp V square B into V, and Kp equal to this one and V beta equal to this one, and finally T by V equal to Kpv into B, and this equation is something similar to Ymx plus C. Now if we plot T by V versus V, then we will get a straight line. If we pass through here, then we have some B value, but if we pass through origin, then beta will be B equal to 0, then the slope will be equal to Kp, and from Kp we can, Kp is equal to equal to this, so we can find out the different other parameters if we want to calculate. Now this is the problem that we have. The following data are obtained for a constant pressure cake filtration experiment. The time is 5 seconds, 10 seconds, 20 seconds and 30 seconds. The volume is increased like this. So volume of the cake that is increased like this. So A equal to this, these parameters are given, and what you have to find out RM value and specific. This is the resistance of the cake and the specific resistance of the cake, both you have to calculate. Now let us see how you can calculate, because I told you that we shall have to plot this T by V versus V, and we will get, and if you look at the straight line, it goes almost through the origin. So we can assume B equal to 0. So we have Kp value. Kp we can easily find out from the slope. This is the slope, and this Kp, once we find out the Kp value, and this is beta equal to 0, so Rm equal to 0, and then we can write Kp equal to this one, and we know mu value, we had Cs value, del P value, A value we know, so we can find out the specific resistance of the cake. So in this particular lecture, I try to point out that how you can how the downstream processing that important in the biochemical industry, that one that is the steps that is common to all chemical and biochemical industry is the separation of the particles. Now separation of the particles can be done by different means. One, with respect to gravity by using sedimentation technique, with respect to force separation by using the centrifugal force, by using centrifuge. So we have, I discussed the membrane filtration, I discussed the cake filtration and cross flow filtration process, and we try to find out the what should the cake specific cake resistance or the resistance of the cake, how the angular velocity of the centrifuge have that is proportional with the percentage separation of the solid particles. Thank you very much.